Yes, I'm okay. I need to upload part 3. Hey, what's up boys? You continue to amaze me with the thoughtful comments and appreciation, which I'm truly thankful for. You guys are the driving force of this ride, and I hope that it never ends. Today, we will dive right into coding the multisheet. We will take all of the offsets from the last video and create a mimic entity in our program to store all of the data and then manipulate it. Now, if you haven't watched the previous 2 parts, then do that right now, or else this tutorial will be incredibly hard to follow, or maybe even impossible. But as always, you can access the source code for only $5 in the Ko-fi page. You can write a comment if you have any problems, or if you want me to notice you. The Discord is available, you know this stuff. Now enjoy this showcase. Okay, so let's take a look at what we will have at the end of this tutorial. Now, we got our offsets from part 2 right here, and in this tutorial we add them to our program. So we will have all of this code in the main program, and we will also have, as I told you guys, our own entity where we can store all of the attributes and so on. We have all of this information at the tip of our fingers. We also have the offsets stored in an offsets class, and we utilize all of these at the end of this tutorial. So we also initialize the IMGUI, so we create the window that we wanted, and we hide the console. So there's quite a bit of stuff that we complete in this tutorial, and I hope you enjoy it. And we're back at the desktop like always, but we don't come empty-handed. We have the addresses and offsets to begin and create this multisheet. Now, these might be updated by the time you're watching this video, but if you followed the last tutorial, you should now know how to get them on your own. So we're all good, and let's open our project that we created in the first tutorial. It's right here, and you should have something that looks the same. So if you don't have this, it should have all of these NuGet packages installed. If you don't have this, watch the first tutorial, just do it. And when you have done that, we can start writing some actual code. Now, we don't have the usual code here because I think I checked the top level thing when we created the program, but it's incredibly easy to add your common namespace class and main method. So the first thing we will write is namespace. This namespace, you can have whatever name you want. I'll just write Left 4 Dead 2 menu. Yeah, that's it. And after that, these brackets. And inside of this namespace, we will write class, and then program, and then overlay, because we will inherit the overlay classes attributes and so on. So to inherit the overlay, we will need to add using clickable transparent overlay like that, and we're good to go. We just need to have a body, and we also need to implement a render function program does not implement inherited abstract member overlay.render. So we will need a render method inside of this class. And it will stop complaining. So we can do that pretty easily with just protected override void render. And it auto generated some new code that I don't want. So at this moment we will leave it be and we will come back later. But now we don't have any errors and so on. And we can write our superclass or our core class, which is the entity. We will create this entity class with all of these attributes. And we will also create a class to hold these offsets. So on the project, you can go full screen. On the project, you can right click and then click on add new item. On this new item, you will choose the class. The class will be called entity. It will give us this internal class entity, and we can write public instead. And let's kind of mimic what an entity would have for attributes and so on, because we will read the data and we will just sort of copy all of the same attributes, the health, the position, the team and so on, and we can easily loop through this entity after that. So the entity will be located somewhere, and the location for this entity will be, at least in this case, we will store it as an address and an int pointer, because we're using the swedz memory library and we primarily use int pointers. The next attribute will be our health. So the health is just your health points. You have 0 health points, you die. So you have 100 when you're full health. The next attribute will be our team. We will call this team num, because in the offset it said team number. So let's just call it team num, so it's easily correlated. After these type of integers, we will actually create a new attribute which needs the system.numerics. The system.numerics have the vectors and so on. And what we are adding now is a vector 3, so a 3D position. And we will call this origin. Why did it autocorrect to vector 3? Why? Again, I need to stop. Get set. So we have an origin position, which is like we found in Ghidra. It's the position at the feet of the character. We will also have another position, another 3D position, which will be vector 3, and we will call it abs. So the location of the abs of the character. I don't know if it's the abs or if it's the torso or whatever it is, but it's somewhere in that region. But it's above the origin. Now, the next attribute will be the view vector offset, or the view offset vector. So it will also be a vector 3, and we will call this view offset. And this view offset is an offset from the origin. So it's the difference between our abs and the feet. So if you stand up straight, it will be it might be 65 units, this offset. If you crouch, the offset is less, and using this method we can calculate the abs position. So we have the view offset right here. The next attribute will be the magnitude, and that's a float, not bad. This magnitude will be the magnitude from the local player, or from you. We'll store that in the entity. We will also store, and we probably should move this one, but we will store the life state. Now if you remember, the life state was sort of a byte in the Ghidra, but we decided to use the life state or read it as an int, so or as an integer, so we can use it for both common, infected, and the normal entities. We have another integer. Let's just write it up here so it's a bit organized. We have an integer that's called, I just call it jump flag, because it tells us if our player is in the arrow or not, and we will use the f flag offset for that. So this jump flag will tell us if we're jumping or not. Alright, so for the moment we're done with this entity class. It's very easily and simplified how we created this. It's not your usual object-oriented method of creating classes and so on, but that's not the point of this tutorial, is it? The point of this tutorial is to create or write fast code so that you get right into learning. You don't have to learn these object-oriented ways. Now, we will create a new class. We will click on new item, new class. We will call this offsets. It will hold our offsets. And I think we can just call this abstract offsets. Nah, that might confuse people, so let's not. Let's keep it simple. So in this offset class, we will have some addresses, local player, entity list, the local view angles, and then some offsets. So the first one is let's add the engine angles first. So this will be an int engine angles. It will be the value of this hex that's on top of this module. Remember to add an x after the 0, so Visual Studio know it's a hex value. But after this engine angles, we also have an offset for the engine angles. So we will just call it engine angles offset. Nothing complicated. We will add the offset like that. Then we have the next one, which we can add let's create some space. So these are engine, these are clients. We will add the next address, which is the entity list. It will equal to this one. And we will actually add, yeah, I added a 0 by accident, that's my bad. But we will add 0x10, because if you remember from the offsets video, we were the first object in the entity list. Our player was the first entity. So we will just add 10 in hex for that. The next address is the local player. The local player is equal to this one. Next we have some entity offsets. So offsets, we will have the health. And I forgot the data type. The life state. We have the F flag, which we will just call the jump flag, like that. Then we have some vec view, which we will call the view offset. We have our vec origin. We have finally the team number. All right, we have all of the offsets for that we need at the moment, and let's go back to our main application. So go back to program.cs. In program.cs, we can add some class variables that we're going to need. So go into program.cs. We don't even have a main method. That's my bad. Let's create that main method quickly, which is called static void main, like that. We have a string array of arguments, and yeah, you shouldn't complain. There we go. We have our main, we have our render. So we will need to add some DLL imports firstly, which will be some functions. So a hotkey will be one function. We will import a function to get the window position, the window size, and so on from Left 4 Dead 2, and we have a function to hide the console window as well. So it's a bit of work, but we'll write them all down. So imports, we can start here by writing DLL import. I might just speed this through because we've done this so many times. Yeah, that might be bad for new viewers, but we have a DLL import, which will be static extern boolean, and it's called get window rect for rectangle. We'll have a pointer to the window, and we will return it as the structure, not rectangle, rect. Please don't autocorrect rect like that. But you can see there is an error, and that's because we don't have a structure called rect yet. So let's create that layout. There we go. Public struct rect. We have a left, top, right, and bottom. That was easy. And we're done with the get window rect. Next thing will be our... Now I wrote another function just to make this getting the window rectangle easier, and I wrote it like this. So rect get window rect like before. I think it's an overload since they have the same name. Yeah, I wrote an overload with, or that only needs the pointer to the window. So if we have the pointer to the window, we will create a new rect, and we will use the get window rect and return it in this rect variable, but instead of just doing the out rect, we will return the rect. So we can call this method and just return the rectangle instead of having to use that out stuff. Now the next import will be the hotkey, which we will use the get async key state like usual. It will have an integer as the parameter. The next DLL import will be the get console window method. So static extern int pointer, it will return a pointer, int pointer get console window. And what we will do with that console window is that we will close it. So we need the next import method, which is called show window. So we can use this show window, but with a different argument to hide the console window. So we need that window pointer, and we also need another parameter, CMD show. Okay, I think we're done with the imports finally. It's a bit painful to write all of these, but we're finally done. So the next class variable will be our aimbot hotkey. So the first hotkey, this is how I like to lay it up. You don't need to do it the same as me, but I like to have a hotkey for the command zombies, and this is the mouse 5 key. You can find the virtual key codes on this page. Or just search virtual key codes and search for your button. So here you can see the X button 2, which is mouse 5 0x06, the mouse 4 0x05, which I use for the special infected. So special aimbot key. should be capital. Alright, so now that we have two hotkeys to use the aimbot, we will add some encoding, and I think we need to be using, let's see, encoding, show potential fix that, using system.text. We'll call this encoding, which will use the encoding .ascii. There we go. This is to convert bytes to string, so we can convert this common affected's name. Alright, so the next variable will be our draw list pointer. Now, it will give us an error because we don't have the IMGUI using IMGUI NET, and that should remove the error. And it didn't. Now, why would that be? Is there a typo? There was a typo. Here we go, my bad. Live debugging or live error fixing. Next thing would be the offsets. Now we will instantiate it because it's not an abstract class. I wanted to make it simple for you guys, so we would just call offsets equals new offsets. Namespace, it might complain. We might need to write using your name for the project. So if you have a different name, you will have to write yours, but using the solution name, and you should be able to get these other classes. So we have our offsets now, and the next important object is the swedz32 library, and we need to be using that as well. Using swedz32. Why do you complain? Yeah, swed equals new swed, and in this constructor we will have to provide the process name. So the process name is Left 4 Dead 2, and that's it. So it's very important to keep it exactly like this, otherwise it will not find a process. It has to be perfect. After that, we will create an entity to hold the information of our player. So this is where it gets good. If you have followed, let's see how far or how long I've recorded for. I've recorded for 27 minutes. So if you've made it this far, good job. Incredible. You have the guts and the will to move forward in this life. It will pay off, I promise. And this entity, which will use our entity class that we created with all of these beautiful attributes, this entity will be called a local player, which is equal to a new entity. Like that. After the local player, we will add a list of entities. So this list of entities will be you have three types of entities to watch out for. And because I have not shown any inheritance between the entity object and so on, we will not go into that. We will just create three lists of entities. So the first list will be called common infected, which will equal to a new list. The next list of entities will be called special infected, which equals to another list of entities. After that, the list of entities would be called survivors. So I felt like this is easier to explain rather than having one entity list and different types of entities in it. So we have 3 entity lists here that we will sort the different entities into these smaller lists. All right. Now that's over. We can create some vector offsets. So vector 3, we'll call this offset vector. Now, this vector is just, it's here to offset where we aim on the zombie. That's it. That's all it does. So we will call it offset vector, which will equal to a new vector 3, and we need to use numerics again, using system.numerics, like that. The offset vector will be equal to a new vector 3, and the values will be 0, 0, and then 15 units. So on the z-axis it's 15. Okay, so we will add another offset vector, and this one is targeted at the common zombie, so or the common infected. So that's why we use the common at the end. All right. Here we will declare some variables for the client. We will declare a variable for the engine. Also, or we will do that later. And at the moment, we're done with the class variables. We will come back to this and add more as we go on. But for the moment, actually, we need a couple of constants. After that, we're done. So here we will write const int sv hide, which will equal to 0, const int show, which will equal to not 1 but 5, and that's the class variables for now. So we are going to, instead of writing a lot of code in this main, we're going to distribute the code to different methods. In this main method, we will create a new instance of program, like that, and we will call program.start.wait. This will call the render, and why do you not start? Program.start, we need the parentheses. This will call the render method, and you will need this, otherwise your IMGUI will not show. So after that, we will get the handle of the console, get console window like that, and we will hide it. Show window, then handle, and instead of show, we use hide, so we don't see that console window. After that, we're done for the time being, but in the render method, we will write our first drawing menu code. So we will create a method beneath it, which is called draw menu. In this draw menu, we will write IMGUI dot begin. We will write the title of the IMGUI window, and I will just call it forwarded to awesome menu, like that. And in this render method, we will call our draw method and also and the IMGUI like that. Alright, so there should be a window that pops up now when we start the application. Let's try it out as the last thing we do in this tutorial. We have recorded for a very long time, 35 minutes, my goodness. Alright, let's instead of having the swedz thing here, add two backslashes for it to be commented out, and let's start the application. If you try to run this without having left it 2 on, it will crash. So with that commented out, let's try our application for the time being. It should close the console window and bring our beautiful IMGUI window up. That took a long time. So, unable to find an entry point. I must have written a typo. That's my bad. Let's fix that now before. Oh, my bad. It's kernel. It's not user 32. Oopsie doopsie. So in the window console, we use kernel 32, and show window is actually user 32. All right, let's run it now. My bad, guys. That's way faster, and you can see the beautiful little IMGUI window. So it might feel like we didn't come very far today, but you actually did. You have a window now. We have the very important core class of the entity. We also have added our offsets, and now we can just add more code. We can add our aimbot method. We can add all of the good stuff, and the groundwork is completed. We can add buttons. We can add all of the good stuff. All right, so I will see you guys in the next tutorial. Peace out. Stay awesome.